Hello everyone and welcome. We are going to try something a little bit different today. I want to start off with saying everyone needs a hobby, right? Some people collect stamps, some people like going to the gym, and some people like to figure out the genetic genotyping of fictional animals. Hello, that's me. Um, as some of you might have guessed, or read the title, we are going to discuss the genetically accurate family tree for both rain and spirit. We're going to start off with an introduction so that everyone knows what I'm talking about, even if you are entirely unfamiliar with genotyping or anything to do with genes and base colors and anything of the kind. Don't worry, I'm going to try and explain it as simply as possible so that everyone can follow along. Right? I want to have a little bit of a disclaimer by saying that all the things I'm going to talk about is very simplified. A lot of these genes, a lot of these alleles have different numbers attached to them. They have different sort of mutations, different sort of strains. I am just going to keep it very, very simple. Now, before we get started, there's a little bit of terminology that I want you all to be familiar with, so you don't get lost, right? We write genes with letters to make them easier to talk about and understand. Each gene gets a short letter name, like capital A or little b, because writing out the full name every single time would just take too long. Capital letters usually mean a stronger or dominant version of the gene. A lowercase letter usually means a weaker or recessive version. So instead of saying the dominant brown gene and the recessive blue gene, we can just say capital B and little b. It's like using shortcuts to describe which gene version someone has. Now, every gene contains two alleles. You get one allele from your mother and one from your father. Alleles are just different versions of that same gene. Every horse has a base color. Think of a horse's base color as its starting canvas. For horses, there are only 3 real base colors every single horse is built from. You have chestnut, which is a reddish-brown body and mane. You have black, which is a solid black body, mane and tail. And there's bay, which is a brown body with a dark mane, tail and legs. Now, I can hear you thinking, well, there are a lot more horse colors out there than just chestnut, black and bay. And yes, you are completely correct. But these 3 are the starting colors. And every other color that you see in horses gets decided by other genes. Now, the 2 genes that I want to talk about in this video, which might just be the 2 most important ones, are called the extension gene and the agouti gene. The extension gene is written with the letter E, and it controls whether the horse produces black pigment, which is the dominant capital E, or only red pigment, which is written with a little e. If a horse has 2 copies of the red form, so little e, it'll be a chestnut, and it means that that horse doesn't show any black anywhere. But if a horse has at least 1 black form, so at least 1 capital E, it can produce a black pigment, meaning it could be either a black or a bay. Now, if it's going to be a black or a bay, that would depend on the next gene that we're going to talk about, which is the agouti gene. The agouti gene is written with the letter A, and it tells the black pigment where to go. So if the horse has at least 1 copy of the agouti gene, so at least 1 capital A, it restricts the black to just the mane, tail, legs, and the tip of the ears, giving us a bay horse. But if the horse doesn't have agouti, the black spreads everywhere, making a solid black horse. So in short, if it is a little e, you get a chestnut. If it has at least 1 capital E and is a homozygous little a, you get a black horse. Or if your horse has at least one capital E and at least one capital A, you get a bay horse. Now, sounds a bit confusing, but don't you worry, it'll get clearer in a minute. So once a horse has its base color, other genes can change its appearance. It's like adding Photoshop filters. There are many different kinds of modifier genes, but there are only a couple that we're going to discuss here. And the first one that I want to bring up are the dilution genes. Now, dilution genes lighten the base color. And one of those important genes is the cream gene, written with a capital CR. If it's written with just a capital C, it's the normal wild type, non-diluted, and it doesn't change the coat color. It's a bit confusing, I know, just bear with me, I didn't come up with these things. Now, if it has a CR, that means it has the cream dilution allele. This is a special version that dilutes red pigments. It's also written as CCR, but I would just simplify it to CR for the sake of this video. If the horse has one copy, it softens the color. For example, a chestnut becomes a palomino and a bay becomes a buckskin. But if a horse has two copies and thus is homozygous, it makes the coat very pale and could even be considered white in some cases, like a cremello or a paulino. Very, very pale horses. So that's the cream gene. We also have the dun gene, written with the letter D. It also lightens the base color, but it adds the quote-unquote primitive markings like a dorsal stripe along the back, leg barring like tiger stripes, often called dunskins. Another gene that I want to talk about is the gray gene, and this gene causes the horse to lighten over time. A grey horse may be born black or bay or chestnut, but it will slowly turn lighter and lighter with age, eventually becoming completely white or like a silvery grey. So in short, a horse's final colour is the combination of its base colour, chestnut, black or bay, and any modifiers. Lastly, I want to touch upon the white pattern genes. Now that you know about the base colors and the modifiers like cream and dun, white pattern genes are quite their own separate thing. They don't change the horse's main body color, they just add white areas on top of it, just like painting whites on the base color. The most common ones are called quote-unquote normal white markings. Most horses, like even the solid ones, can have small white markings like socks and stars and snips and blazes, and they can happen naturally and seemingly random. They are thought to be polygenic, meaning that many genes work together to control how big or small they are, and therefore they are not represented by a single letter. They're just called normal white markings. Now, a horse can also be dominant white, and dominant white is represented by the capital W, meaning that the horse is almost fully white. It is possible that there are still some small areas with color, but those would be very minimal. These horses will still have their base color underneath, of course, but of course we aren't able to see it because all the white patterns has completely obscured it. So in other words, a horse with a pure black base and the dominant white pattern still carries those black genes and can still pass them on to their offspring, even though that horse, that technically black horse, is going to look completely white. Other common white markings or white patterns are Tobiano, which is represented by the letter T, and Tobiano causes white patches that can cross over the back. Another one is Frame Overo, which is represented by the letter O. Now, Frame Overo causes white patches on the sides but not on the back. If a horse is homozygous for Frame Overo, it can cause something that we call lethal white. Lethal white is, as it says on the tin, lethal. So any foal who carries two copies of the Frame Overo gene is not going to survive. Another white marking that we commonly see is called splash white, which is represented by letters SW. It causes white to come from the bottom up, giving like a splashed appearance. Like imagine a horse who has run through a river of white paint. And especially in splash white, blue eyes are quite common. In all of these markings, blue eyes is quite common when the white covers the eyes as well. A fourth one that I want to touch upon is called Sabino, represented by SB. It causes white stockings, white from the belly up, and more of a speckled, rony white edges, like it's not as clear as the Tobiano. Then the fifth one is called Tovero. Tovero is a combination of Tobiano and Overo traits. Now the Sabino, the splash white, and the frame Overo are all considered to be Overo traits. So any of those three plus Tobiano is called Tovero. Sometimes it is quite hard to see what these markings are if you're just looking at a horse, because all of these white markings can quite vary in their expression. You could have, like I said, a dominant white who is completely white, or you can have a dominant white who still has some areas of color. You can have a splash white horse who looks like it only has white stockings and maybe like one or two white spots in his belly. So it does have quite a degree of variation to it, which makes it quite difficult to say, just by looking at a horse, what these genes, white pattern genes are. Now that we have all the terminology out of the way, let's get into the family trees. We'll begin at the oldest generation and work our way down, so let's get right into it. First off, we're starting with a horse hardly anyone knows exists in the canon lore, and that is Alma. Alma is Spirit's maternal grandmother. We have no information on the grandfather, so that makes things a little bit easier, as we can easily give the genes that we might be missing to his grandfather. Now, Alma is described in the 2002 book series called Spirit of the West, authored by Kathleen Dewey. Most of the horses in this family tree come from these books, which are, by most, considered to be canon. Alma is described as a small-boned and delicate-looking horse. She has a lovely face and her eyes are a deep coppery color. Her buckskin coat was still rough and thick from winter, but once the weather warmed up, Esperanza knew the fine gold-brown color would shine in the sun. Her mother's mane and tail were black, and her own was snowy white. Now that's all of the description that we have of Alma, but that's all we need. So let's get into it. We know that her color is a buckskin, so that means that she needs at least one capital E for the extension gene for that black pigment to be expressed. When we are going to have a look at the Agouti gene, she's also going to need at least one capital A to make her bay colored. Because of the capital E, she can express the Agouti, resulting in the black mane and tail. If we have a look at the cream genes, she needs at least one capital CR for her bay color to become quote-unquote golden, aka a buckskin. She doesn't appear to have any dun genes, nor grey, nor white patterns. So easy, right? She's just a regular buckskin. Next up is Spirit's mother, Esperanza. Esperanza, both in the movie and the books, is a palomino, which means she has a golden coat, pale mane and tail, no dorsal stripe, she has a blaze on her face and white stockings. Now it is noted that she doesn't show these white markings in the books. However, as the movie version of her is the most popular, I will include these white markings. So let's get into her genotyping. If we have a look at the extension gene, we know she's a palomino that comes from a chestnut base, so she is homozygous lowercase e. If we have a look at the Agouti gene, I am going to cheat a little bit. Well, it's not really cheating, but I know that Spirit is a buckskin, and I don't want to really, rush ahead, but I know that his father is a solid black horse. That means Spirit has to have at least one capital A, which can only come from Esperanza. Now, so we're going to give her a capital A. Now, some of you might be wondering, well, hang on, how can she have a Brey gene, like an agouti gene, even though she's a palomino? She can carry the agouti gene without showing it, because agouti only affects the black pigment and not the red pigment. Agouti controls where black pigment appears, so it tells the black color to stay on the mane, tail, legs and tips of the ears, creating a bay horse. But chestnut-based horses, like Esperanza, can't make black pigment at all. They only make red pigment. So if a horse has no black pigment, then agouti has nothing to work with. It's like giving a shovel to someone in a concrete room and asking them to dig a hole. They can try, but it's not going to make any difference. So we know she carries the agouti gene because her mate, Strider, who is a pure black horse, I can already tell you that, can only give Spirit a lowercase e. But in order for Spirit to express the black pigment, he will need at least one capital E, which he can only get from his mother. This is called a hidden or a masked agouti. Moving on to the cream, we know she has at least one, well, we know that she has one cream gene because she is a palomino and she's only been diluted once. We also know from her design that she's not carrying any dun genes because she's not showing any of those primitive markings. She doesn't carry any grey genes, and she just has normal white patterns, meaning she has stockings and a blaze. Now let's have a look at Spirit's father, Strider. Strider is not seen in the movie, but only briefly mentioned as having been the leader of the herd before his son took over. All info that we have on him comes from the book series as well. Now, luckily, he appears to be one of the easier ones to figure out, as he's described as a solid black horse. So, if you have a look at his genotyping, the extension has to be either homozygous or heterozygous for capital E. He must have at least one capital E to show his black pigment. His agouti has to be 2 lowercase a's, because he's not a bay horse, he is a solid black horse. He doesn't carry any cream genes, so that's 2 capital C's. He doesn't appear to have any dun genes, no grey, and no white pattern. So, well, spoilers, this is going to be the easiest one to genotype. Hold on to your horses, because it's getting a lot more complicated very, very soon. We have finally come to the titular character, Spirit himself. As I said before, Spirit's quite an easy one to figure out. He is a buckskin. When we have a look at his design, he has a golden body, black points, meaning black on his legs, his nose, his ears and his tail. He also has a thin dorsal stripe. Now remember that, because that's going to be important later. Let's fill in the genotyping. He needs to get at least one capital E, so he can get that from Strider and a lowercase e from Esperanza, which means he can express the black pigment. Looking at his agouti gene, he gets a capital A from Esperanza and a lowercase a from Strider, which turns him into a bay horse. Now, because of the capital E, he can express the agouti, resulting in the black mane and tail and legs and muzzle. He carries one cream gene from Esperanza, which turns him into this golden color, aka the buckskin. He doesn't carry any dun, because neither parent is a carrier. He doesn't carry any grey, and he doesn't have any visible whites. Now, but hold on, I hear one of you say. You told us earlier that a dun dilution gives dorsal stripes. But if Spirit is a buckskin, and thus a bay horse, how can he express his dorsal stripe if neither parent has given him a dun gene? Well, actually, I hear someone else say, the real fans know that Spirit is a dun skin and not a buckskin because of the dorsal stripe. Therefore, there must be something wrong with either Esperanza or Strider's genotyping. And to that second person I say, you are wrong. Buckskins can express a dorsal stripe. Now this happens because of something called countershading. What is countershading, you ask? It's a natural blending of darker and lighter colors on the animal's body. We don't just see it in horses, we see it in other animals as well. And it helps animals to blend into their environment better. It's a form of camouflage. In horses, countershading can create darker shading around the top line, making it look like they have a dorsal stripe, even though they don't carry the dun gene. Now, a real dun dorsal stripe is usually very sharp and clean-edged, and often comes with other, the quote-unquote primitive markings like the leg bars and the shoulder stripes. But a countershading dorsal stripe tends to be softer, a bit fainter, not as sharply defined, and the horses usually don't show these other primitive markings such as the leg bars or the shoulder stripes. Now with Spirit's brown dorsal stripe, I think it's fair to say that this is due to the countershading. So the conclusion is he is still genetically a buckskin and not a dunskin. Now it's time for Rain's family tree. Ironically, we know more about Rain's family tree than we do for the titular character himself. And all of this info is, you guessed it, from the book series, which is considered canon. So let's start off with Bonita. Bonita is Rain's maternal grandmother. She is described in the books as having white and gold in cloud shapes across her back and belly. It's also mentioned that she is quote-unquote bloodstock, aka a thoroughbred. Now, while many fans claim that she is white with a grey muzzle, there is, well, at least I couldn't find any mention of a grey muzzle on her anywhere in the books, and is most likely a fan interpretation of her. Luckily, it can easily be explained as her skin just showing through the thin white hair on her muzzle, and thus doesn't require any genetic explanation, so go ahead and give her a grey muzzle, if you like. So this is all we know of her. The colour of her eyes is not described. There are a couple of options on what sort of genetics she might carry. The paleness of her coat and the inclusion of the white and gold cloud shapes makes me think she could carry some extreme dilution genes, and thus making her like a very, very subtle Paulino or Cremello, like a double dilute. But also, because of those cloud shapes, we can also be quite certain she does not carry the dominant white gene, because otherwise those spots would be either invisible, or if she's like a low expression dominant white, she would still show these spots in adulthood. But she's described, when she was born, as having these white and gold cloud shaped spots. But in the rest of the books, she's just described as pure white when she's an adult. Which makes me think, okay, well, these spots are gone, right, when she's older? Now, we'll start off with the most obvious option and then work our way from there. The most obvious option, as I said, is a double dilute Tobiano. And in this case, we're going to go for a Cremello. So if you have a look at her genotyping, she has to be a chestnut base in order to become a Cremello, which means lowercase e twice. A Agouti gene? Currently unknown, and at this stage, not really necessary for the rest of the family tree. We'll leave it open for now. I said she's going to be a double dilute, so that means a double cream, which turns chestnut into Cremello. There are no dun characteristics, so lowercase d twice, no graying genes, and as for the white pattern, I'm thinking a Tobiano, capital T, for those smooth white quote-unquote cloud-like patches over her back and belly. This is currently what we know, but don't get too comfortable though, we will absolutely be getting back to her in a bit. We'll leave Bonita for now and move on to Rafael. Rafael is Rain's maternal grandfather. Although he has been featured as a written character in the book series, there is no canonical visual description of him. He's described as a palomino with a smoky mane and tail. That's all we know of him. So that means, when we have a look at his genotyping, again, he is chestnut based, so homozygous, lowercase e. Agouti is currently irrelevant, as a chestnut horse cannot show any black, as we discussed earlier. So he can be either homozygous or heterozygous. For Agouti, it doesn't really matter at this point. He needs at least one cream gene for the palomino, and again, no dun, no grey, and no white pattern that we know of. But some of you might be asking, how can Rafael have a smoky mane and tail when he's a palomino? Because palomino genes, or the single cream dilute from chestnut, means that the mane should be somewhere between white and a cream, definitely not smoky. Now there is a gene called the sooty gene, often written as SM. Genetically, the sooty gene is not mapped yet, and we currently have very little information on how it behaves. This sooty modifier causes dark shading, usually over the top line, the mane, the tail and the lower legs. Moving on to the daughter of Bonita and Rafael, Sierra. Sierra is Rain's mother. She is described as a brown horse with white spots across her body and white legs. Now, we've already stumbled upon our first problem, because in order for her black pigment to show up, in order for her to be a brown horse, she will need at least one capital E from one of her parents. But her father is a palomino and thus has to have two lowercase e's. So the only option is that she gets it somehow through her mother. But if we go back to her mother, back to Bonita, we said that she's chestnut based, so she has to have two lowercase e's as well. Now, the current assumption is that she is a chestnut with a double dilution, making her a cremello. But here's the interesting part. Double cream on a bay or a black horse would still make a pale-colored horse, just with a different undertone. So if we give a capital E to Bonita, making her express the black pigment, and if we give her at least one capital E for Agouti, plus a double cream, she would be a Perlino and not a Cremello. Perlinos can appear very, very similar to Cremellos, only their mane and tail might be just slightly smokier or orange gold and not quite snow white. So, in this scenario, Bonita could have been misidentified as a Cremello when she was really a Perlino. So, if we then go back to Sierra, that fixes the extension gene problem. But when we have a look at the cream gene, we have another issue. Sierra is a brown horse. That means she cannot carry any cream dilution. She can get a regular C, so a non-dilute from Rafael, but we just mentioned that Bonita only carries a double dilute gene. So we have to go back to Bonita and try to fix it. Now, get this. Instead of being a Perlino, instead of being a dominant white horse, instead of being a Cremello, Bonita, wait for it, is a Tobiano buckskin. Hear me out, I know what you're thinking. She's a white horse. How on earth could she be a buckskin? Well, she's a buckskin who has the graying gene. The white patches are from the Tobiano, and her near white coat comes from graying over a cream or bay base. So she just happens to be a very pale buckskin to begin with. So, going back to her genotyping, we know she has at least one capital E to make her black based. She has at least one capital A to become a bay horse. Now she can have a single cream gene to become a buckskin, no dun dilution, and one graying gene, which turns her coat grey over time. This also explains why she was described with the golden spots at birth, but every description of her afterwards simply describes her as white. Looking back at her white pattern, I think she's still a Tobiano, and she might also be carrying the Sabino, which might help soften those edges and add some more white to her. And that would cover most of her in white anyway. The grey gene will eventually cover up all the buckskin colour and turning her into a completely white horse. Looking back at Sierra, that fixes all of her problems. She can now have no cream gene, so no dilution. She doesn't have any dun characteristics. She doesn't carry any grey. And she can still carry the Tobiano from Bonita. She also may be carrying Sabino or Splash White, but I consider those to be optional. Her book cover artwork suggests that she is a low expression Tobiano. Let's move on to Sierra's mate and Rain's father, Storm. Like with Rafael, Storm does not have a canon visual depiction, but is clearly described in the books as a black and white pinto. There's no mention of dilution, dun, grey, or any visible red or bay tones. He's going to be a very easy one to genotype. Now, pinto means any color plus white pattern. So, we know he's a black horse, so that means he needs at least one capital E for the extension gene. He can't be homozygous because he has to give at least one lowercase e to Rain later. I know that for a fact. We're not going to jump back like we did with Bonita. I'm just going to spoil it for you. Looking at the Agouti gene, we know he's a solid black horse, and the only way to make him solid black is make him a double lowercase a. He doesn't carry any cream dilution, no dun, no grey, but he's a pinto, so we're just going to say that he carries the Tobiano gene. He might carry some other ones, but Tobiano is the most likely. And last we've come to Rain herself. We know she's called an American paint horse, and she is described as a bright reddish brown sorrel tovero with a blonde mane and tail and blue eyes. Now, just to be clear, sorrel is simply a cowboy term for chestnut. Red also means chestnut. Reddish brown means chestnut. So, chestnut base, yet again, twice lowercase e. And she can get that lowercase e from both parents, so we're good. Agouti is irrelevant on her base as it won't show anyway. So she can be double lowercase a or capital A lowercase. Doesn't really matter. We know she doesn't have any dilution because neither parent has a cream dilution to give her. She has no dun, no grey, and she has at least the Tobiano from her father, but she might also be carrying the Sabino. It doesn't really matter, but, well. But where does her blonde mane and tail come from if she's a chestnut and not a dilute? The most likely explanation is the flaxen modifier. Flaxen modifiers is a genetic trait that lightens the mane and tail of a chestnut horse. It's not caused by cream, dun, or any dilution. It is not yet mapped to a specific gene, but we do know that it is recessive. It can only affect red base horses, so double lowercase e like Rain, and only if they inherit 2 copies of the gene. So a black or a bay horse could carry the flaxen gene, but it wouldn't show up on their coat, just like how Agouti doesn't show up on red-based horses. Now the flaxen gene can make the mane and tail appear somewhere between golden blonde and white, even on the very darker colored chestnut horses. Some chestnuts may even almost look palomino-like due to this flaxen effect, even though they carry no cream gene. Rain's chestnut base allows flaxen to be visible, so if she inherited a copy from both parents, the trait will show, and this would make her mane and tail distinctly lighter than her coat. It's entirely possible that her parents and grandparents all carried a single copy of the gene, as it wouldn't affect their appearance. So the only one in which it could matter is Rafael, because he's also red-based. Though, as a palomino, it would hardly make a visual difference anyway, because, well, his mane, because he's a palomino, would already be quite light. And with that, we have come to the very end of this family tree. I know some of you might be asking, well, what about that spin-off series that appeared a couple of years ago, where, they have the Spirit Junior, like the weird spirit-looking horse that is supposed to be the offspring between Spirit and Rain? And, well, according to most, myself included, that series is not canon, so I'm not going to discuss him here. So with that, we have officially come to the end. Feel free to let me know in the comment section what you thought of it. If you enjoyed the series, maybe you have another family tree that you want me to discuss. If I made a mistake, feel free to point it out. I'm just a hobbyist. I'm not a scientist, so please take everything with some grain of salt. And I hope you enjoyed it as much as I did. Maybe you learned something new, maybe you didn't. But, keep on galloping. Bye.